And we're now to move into what's called the interior low plateaus, level 3 ecoregion. So we are now stepping off the plateau out of the green ecoregion here that's number 68, and we're stepping into what is called ecoregion number 71. It's highly complex, lots of variation here. Ecoregion 71, we often refer to it as the ILP, or the interior low plateaus. Sometimes we just simply call it the interior plateau. But it's got a lot of subdivisions, and this is where Clarksville and Nashville and Lexington and Louisville, Kentucky are. These are all cities that are located within the interior plateau. Do you have any questions before we get going with the interior plateau ecoregion? Okay. First of all, what I want to do is kind of divide the ILP, as we call it, sort of into two sections. We're first going to talk about the areas that are relatively low and are dominated. And these are areas that kind of form what we call basins. They're low with respect to the regions around them, which are more elevated, hilly plateau regions. First, for starters, we're going to start with the Bluegrass Basin, simply called the Bluegrass by most people. That's the area up here in Kentucky, and you can see it sort of this area that kind of, I'm showing the southern limit of it with my cursor here. This is the Bluegrass right there. The cities of Frankfort and Lexington, Kentucky, and Louisville are all located within the Bluegrass. So is Cincinnati, by the way. And then next, we're going to talk about the Nashville Basin, which is here in central Tennessee. Gets barely into adjacent southern Kentucky and just a little bit into in northern Alabama. And then the last of the three that we're going to talk about is not really a basin at all, but I put it in here because it is mostly limestone dominated, and that's called the Molten Valley. And it is an area that's sort of depressed, meaning like lower with respect to the regions around it. So like this region, I call it 71X because it's not traditionally treated as its own separate ecoregion. But it's this little valley here that runs east to west, bounded by the Cumberland Plateau on the south. And then it's got a little line of hills just north of it called the Little Mountains. And we're just going to focus on that little area there, which is called the Molten Valley. Now, before I go any farther, let me ask you, what is the northernmost boundary of the interior plateau formed by? What created this very jagged, irregular boundary up here on the north, shown by the red arrows?
Could it have been glaciers?
Yeah, great, Brandon. That's exactly what that boundary was formed by. That's the southernmost edge of the glaciers during the Pleistocene Ice Age. And those glaciers were moving very irregularly over long periods of time. And that's the southernmost area that we know that they have extended to. That line is pretty well known. It's mapped by geologists. And so we call that the LGM, or the the last glacial maximum. I'm going to put that in here. LGM. Make sure you know that. Last glacial maximum. And that basically is the southernmost edge of glaciation during the Ice Age. Okay. Now, how far back in time? Does anybody want to hesitate to guess when that edge was first sort of established?
1 million years ago.
20,000.
That's a really good guess. What was the second guess?
20,000.
That's also a good guess. You guys are both real close. So the answer is it depends, because there have been numerous glacial advances over the course of the last 2.5 million years. And we're going to talk more extensively about this in a future lecture, but at various points, glaciers moved, in some cases, as far south as the Ohio River in some places. And at other times, they may not have moved as far south. So like take Illinois, for example. If you look at the state of Illinois, the southernmost place where glaciers extended to at their very maximum ever was this line right here. And you can kind of see it right here by my cursor. But those glaciers came to that southern place in Illinois around 1.8 million years ago. So it was a very, very long time ago. Then there have been other glaciers that advanced over and over again, and they didn't come as far south. So like, for example, the one that came here, 20,000 or 18,000 years ago, those glaciers mostly stopped up here near Springfield, Illinois. So it really just kind of depends on what glacial episode we're talking about. But what this line, the LGM, helps us to understand is it's the point of southernmost extent of glaciers ever, whether it was one of the glacial events from 20,000 years ago that established that line, or if it was an earlier glaciation event, let's say 1.8 or 2 million years ago that established that line. That's basically what we're saying, is this the southernmost edge of glaciation ever? And what's clear from this then is that the glaciers never reached our immediate vicinity. They came close, right? They came within 150 miles. If you look here from Clarksville, for example, to the northwest, then you can see that the glaciers got to be very close to the Ohio River here in southern Illinois. Now, there is one other piece here that I want to just point out, and that's this sort of triangular section right here, shown by these regions 72H and 72C and 72A. There's been disagreement by past physiographers as to whether or not this region is part of the interior low plateaus region, or if it's part of another region, region 72, which is called the central lowlands. I happen to believe that this is part of interior plateaus, and I'm going to teach that to you, and that's a little bit more of an outdated philosophy. The current trend, as you see from this map, is to separate this from the interior plateaus and to put it with the central lowlands. I just disagree with that. So I'm gonna recommend that we call pretty much everything, at least here in 72C and 72H. Those areas in particular, I'm going to teach to you as part of the interior plateau region. All right.
I got a glacier question.
Yes, please.
Thanks. And it sounds elementary. Well, that's where I am. I always see glaciers like you see them on the edge of a body of water where they're calving, right?
Yeah.
So what is this bottommost line and these glacial maximums do I envision it as a blunt edge like we see when they calve? Or is it kind of a long tapering thing that's just like a long finger reaching out? Or what does that look like?
That's a fantastic question. And not being a glaciologist, right? We were at a really cool university. We might have a whole class on glaciers, but yeah. Hey guys, if you can, just make sure you mute yourself back here in the background, and that way we can, yeah. So yeah, I think you would have had a combination of things. In some places, that glacial edge would have been very precipitous, very steep, and it would have been calving off. And then in other cases, it might have been a little bit more of a gradual taper.
Okay.
I don't know the specifics of that. I will say we're going to get into that more deeply here in a few weeks.
Okay. Thank you.
All right, you're welcome. Give me a second. All right, so great question, and we're gonna cover glaciers much more extensively here in a couple of weeks, and hopefully I did your question justice there, Laura.
Sure did. Thank you.
Okay, so we're gonna hit Bluegrass Basin, Nashville Basin, and the Moulton Valley, and then we're gonna come back in what we call Part B, and we're gonna talk about the non-basin sections. These are basically the more elevated parts of the interior plateau, such as the Highland Rim and the Pennyroyal Plain. And these form these more elevated tablelands that encircle these lower basins. And these more elevated sections, typically, they can have limestone, but they often tend to have like other kinds of rock types, such as chert or sandstone, which makes a lot of sense because they're more elevated, and the harder rocks that they have means that they're less prone to erosion. Okay, so here just another way to sort of visualize this. Again, bluegrass, Nashville Basin, and I want to add two little areas that are not formally recognized as separate ecoregions by most classifications. I've already told you about one, the Moulton Valley, and then I'm going to introduce another one here that is called the Cumberland Enclave. And this is an area that is showing specifically right here, where the Cumberland River comes down out of Kentucky into Tennessee. It's a really gorgeous area and represented by the abbreviation CE here. The Cumberland Enclave was recognized in some reports written in the 1970s, but generally speaking is not recognized broadly as a separate Level 4 ecoregion anymore. I think it probably should be, and I'll talk to you more about why that is. The Nashville Basin consists of both an inner and outer ring, and so Nashville is located in the outer basin, and you can see the inner basin here is just to the east of downtown Nashville. So if you're familiar with where Murfreesboro is located, or the town of Shelbyville or Lebanon, those are example towns that are located within the inner Nashville Basin. And then cities like Nashville, Columbia, Pulaski, Fayetteville, Carthage, these are all towns located within the outer Nashville Basin. The Nashville Basin wasn't always a basin, though. Originally, it was a dome. It was a geologic dome, which basically means it's an area that was geologically uplifted at some point in the past. And the various rock layers have sort of a convex shape. You can see that they sort of convexly arch or bend. And if you were to look at this dome, the high point of the dome used to be, kind of right over the city of Nashville, or between about where Nashville and Murfreesboro are located. And then today what we have, of course, is that the surface of that dome, several hundred feet of rock, has been lost to erosion. And you can kind of get that sense by seeing that. So what was once an uplifted dome is now a down-cut, eroded out, sort of bathtub-shaped basin. We can look in the edges of this basin and see the rock layers here over to the west and to the east of Nashville. And they're the same layers on both sides. And you can look at the stratigraphy, or the layers, and determine that they have enough tilt that they would have historically been connected. The primary layers that form the edges of the Nashville Basin are the Fort Payne Formation here at the top, sort of forms the top rim of the bathtub. And that's a chert outcropping that basically is very hard, extremely erosion resistant. Below that layer is a dark black layer. It's kind of blackish brown of what's called the Chattanooga Shale. And it would have gone across historically all the way to the other side. And it's only about 10 to 20 feet thick, just for comparison. And then finally, below the Chattanooga Shale are various layers of limestone. And these are all connected mostly to different geologic periods. So the very bottom of the basin is all Ordovician age, so roughly 500 million years ago. And then slightly above the Ordovician rock layers on the sort of the lower side slopes, you have Silurian age limestones. Then you have the Devonian age shale. And then on top of that, where you have Mississippian age limestone and chert of the Fort Payne Formation. So the Chattanooga Shale then is the layer that kind of represents the technical geologic boundary, separating the highland rim from the Nashville Basin. So if it's up here above that layer of shale, we call it highland rim. If it's below that, we tend to say that it's in the Nashville Basin. That's the technical geologic boundary of those two. Any questions about that? Okay. Now, here's a photograph of that Chattanooga Shale layer. Anytime you're driving along the interstate from Clarksville to Nashville, there's a very specific place that I can share with you where you can see that. And these shale layers have this blackish color. You'll see that they flake apart real easily. That sample of shale that I pass around in class a lot of times is from this Chattanooga Shale Formation. It's very brittle. It's very rich in uranium and radon, and that's the reason why if you live above this layer especially, you need to have radon tests in your houses, in your basements and crawl spaces, because excess radon buildup can lead to cancer-causing conditions, carcinogenic, especially causing various forms of lung cancer. All right, the inner basin, let's start there. It's an area that is Ordovician in age. So this is really at a point, guys, where you need to make sure you're studying that geologic chart of the eras and periods and epochs, because recall that for our midterm exam, that's going to be one of the big things I'm definitely going to test you over. So this is Ordovician age limestone. It's common, lots of fossils here in this region. There's a lot of mix of woodlands and forest and grasslands historically, a lot of open rocky habitats we call glades. And you'll notice here as part of this ecoregion tour, I'm going to start throwing out more ecosystem terms as well. Things like glades and barrens and wetlands. And I want to start using those as part of your common language so that by the time we really get to that part, you've been thoroughly exposed to that. The inner basin is relatively level. It has some gentle undulating topography or sort of rolling, but there are then these isolated hills that you see in the distance called knobs. And by the way, in Google Earth, you can go down into pretty much any place on Earth and look at the landscape in three-dimensional view. That's what I'm doing here. And it allows you to sort of visualize what the landscape topography is like. And of course, if you do it on a street, where the Google cars have been driving and capturing, photography. Then, of course, you can also get what's called Google Street View, and you can use that, to do all kinds of cool research and look at places and scope places out. Some of the, there's a lot of public spaces, public natural areas within this region, like Cedars of Lebanon State Park and State Forest over in Wilson. The biggest cluster of extremely drought-prone, desert-like grasslands, and they are home to numerous species, about 20, that are endemic to this ecosystem. Beautiful shot here showing the spring. One of the class field trips that we're going to go on this year is we'll take a trip to the glades and study those and take a look at all their cool features. This region is also home to one of the most biodiverse rivers in North America, the Duck River, which flows across the Nashville Basin to the south of Nashville down near Columbia, is one of the longest undammed rivers in the South. It has one of the longest undammed sections of rivers in the South, but it does have 2 dams on it. And but the river is highly biodiverse, reportedly with more fish species and more mussel species than any other river in temperate North America. Arguably one of the most biodiverse rivers in all of the Northern Hemisphere. Just tremendous diversity of species. Lots of mussels. Sadly, many of the mussels across the Southeast region, these mollusks have been heavily decimated by the damming of river systems and water pollution. The duck still remains a stronghold for mussels, but even still, mussels are collapsing left and right, and many species are still threatened with extinction. Stones River National Battlefield in Murfreesboro, Tennessee is a good example of a historical sort of archaeological park. It's a place where they had a major Civil War battlefield. In fact, my third great grandfather, I told you, that was in the Battle of Chickamauga, was actually a few weeks or so before that was in the Battle of Stones River. So many of the same soldiers were in those same battles. A lot of people died in these battles. So you can visit these places and read about not only the history from the perspective of the time of the Civil War, but you can also see a lot of the natural features, the woodlands and the glades and the rivers that are on these parks. So they make great public spaces.
I got a
The outer
question.
Nashville Basin yeah, go ahead, Laura.
Sorry, on that photo, is that erosional? What rock is that and what layer and what's the story?
Yeah, this is all what's called Ordovician limestone, and it's what we call the Stones River group. It actually has its own name that sort of reflects the fact that it was first described from Stones River.
Okay.
And some of the limestone in this region which forms like here, it's very massive, very thick limestone, right? It's you know, rich in fossils, but it's very thick.
Right.
And these are all sort of from surface level erosion because of these karst features. And so
Okay.
the acids and rainwater are kind of eroding it down. But if you get out there on those limestone glades, like I showed you a couple back here, notice this limestone is very kind of thin. It's called flaggy. It means it kind of breaks into flagstones and gravel.
Right.
And it's a different limestone that's called the Lebanon limestone, named for Lebanon, Tennessee. So geologists have named these different types of limestones and formations based on their position and their age and their fossils and all those kinds of things. That's part of the study of stratigraphy.
Thank you.
You're welcome. And then, of course, there are different limestone layers, like in the face of this cliff, that are important. The outer Nashville Basin then is slightly higher elevated in some respects. It sort of surrounds the inner basin. It's more of a hilly region. You can see the western edge of the outer basin comes up against the western highland rim. And where that happens, then you expect an escarpment. We're going to talk about several different escarpments in this class, in this lecture. And we've already talked about the Plateau escarpment, for example. But this is the Highland Rim escarpment, which grades in from the Nashville Basin to either the Western Highland Rim on the west side or the Eastern Highland Rim on the other side. And then there's a few parks in this region. Mostly it's private, a lot of private land in the Nashville Basin. But Bell's Bend Park in Nashville, which is about probably 1,000 acres or so, the bottoms of the Cumberland River. It's a great place to see typical outer Nashville Basin scenery. A lot of the basin, the outer basin and the inner basin, have been heavily affected by people. And these areas have been settled and you know, habitated for, you know, 10,000 years by Native Americans. There's a very long and rich legacy of people living in the Nashville Basin since the end of the Ice Age. In the middle of the basin are these occasional clusters of hills, like Radnor Lake State Park in Nashville is a great place to see some of these hills. It's surrounded by this typical sort of outer Nashville Basin, gently rolling to undulating landscape. But then right there at Radnor Lake, you get this beautiful cluster of hills that are elevated. And you'll see this in other places too, like over in Rutherford County. And I refer to these as the Nashville Basin knobs, but they have not really any formal name usually. Sometimes they're called like the Elk Ridge or the Duck River Ridge. Those are some other names for some of these. In this, this is a revised map that shows some changes that I have myself and one of my former students a little bit dissatisfied with the ecoregion maps. We sort of started creating our own ecoregion map to update it for Tennessee. And what you can see here is the inner basin, and then the lighter blue outer basin, and then take a look at what we call the national knobs. And so, for example, Radnor Lake, I just showed you here in the background, would be right in this region. There's a big cluster of these knobs, especially in the southern part down here. And there's the Highland Rim escarpment on either side. The Nashville Basin gives way to the Highland Rim, climbs up onto the Highland. And these are the knobs. All right, any questions about that? Well, as you might expect then, the geology of these knobs is what you would expect of the adjacent Highland Rim, right? If think about it, if the whole basin used to be this uplifted dome, then whenever we find hills in the middle of the basin, those sort of preserve that those rock layers that have been lost now that have eroded down. So we can look in to the sides of these and sort of do a cross section. Here we're looking down on top of one of these knobs in the natural basin. And these basically are erosional remnants of the highland rim. So at the very top in orange here, this layer that's called MFP stands for, this is a very important point. I want to make sure we're all kind of listening thoroughly on this, because I'm gonna teach you a little bit about how to read a geologic map here. These different layers that you see are kind of overlaid with a topography map. You can see the contour like 700 foot contour right there. And then you climb up to the top of the hill and there's the summit of Nodgrass there, right? Now we want to look at the different colors and what they mean with the different codes. If you look down here at the very bottom of this, you can actually see a cross-sectional diagram that shows a couple of important things. One, the sea level. You know, here we're talking about basically scale that are 100 feet down at the bottom and sort of the zones. The tops of the hill are at about 1,000 feet. Right here with the orange, you can see at the very summit of that hill. So when you look at these geologic maps, it's important to realize both what you're seeing from the top-down perspective and also that cross-sectional perspective. Okay, it's important to think about elevation and topography. Now what we want to do is focus on what those layers mean, those layers of the cake, okay? So let's go down to the bottom again, and you're going to see that the lowest layer that we can really see here in this cross-sectional profile is this very light blue at about 500 feet elevation, maybe 600 feet. That's the layer here represented by OH, okay? Then above that layer is the dark blue layer, which is represented by OB, right? And then next is the pink layer represented by OLCY. Let's just take a minute to reflect on what those different codes mean. So does anybody first, let's start with OH. Who knows what OH refers to? Before I ask that in that way, let me step back. What does the O in OH refer to?
Ordovician.
Exactly. Ordovician. See how important those geologic periods are, right? That's a critical rock that's of Ordovician age. So that's what capital O stands for. Notice that all letters in the capital, and then the rest of it is lowercase. So in this case, what do you think the S stands for here in the green region? That's SBR.
Silurian.
Yeah, that's the Silurian, exactly. And same thing with SW here, that's Silurian. And then what about the orange here with MFP?
Mesozoic.
Okay, so that's an era, and we tend not to use eras very much in the geologic map. So this would be a period. What period starts with an M?
Mississippian.
Exactly, Mississippian. So here, and they should be in sequence, right? Ordovician's at the bottom, and then we have Silurian on top. We then could have Devonian right above that. But remember, the Devonian layer, the Chattanooga Shale layer, is only about 10 feet thick. So there's a real good chance that it may not actually what we call outcrop or show itself in the side of the hill profile. And so these are only the places where these specific rocks are exposed. Maybe let's say, as part of an outcrop on a slope or, something like that. And then the Mississippian layer is at the very top of the hill. It's made out of chert, and therefore it sort of forms an erosion resistant cap on top of that hill. So very good. That's what those capital letters mean. Now let's talk about what the lowercase letters what those mean. Any thoughts there?
That's tough.
That's tough. Yeah. I'll go ahead and make it easy for you. Let's use OH, for example. The H is the specific name of that particular kind of Ordovician rock. So in this case, it's the Hermitage limestone, named for Hermitage, Tennessee. Then, if we have in other cases, we might have the OLB, which would be the Lebanon limestone of Ordovician age. I'm forgetting now what LCY and BC stand for, but we could easily look those up on a geologic map. And a little bit later in this lecture, I'm going to pull out another geologic map for West Tennessee, and we're going to do the same thing. We're going to sort of read it. But I mainly wanted to introduce that to you now so that you've had some exposure with how to interpret these geologic maps. All right, let's talk next. We're going to move from the outer Nashville Basin into what's called the Cumberland Enclave. And if you recall, this is that northeasternmost corner of where the Cumberland River comes down. I'm going to just go back here just to show you a little bit. I didn't realize I had to go back that far. We're talking about this area up here in the northeastern corner. River comes down out of Kentucky. It's a very narrow, very very beautiful region of the state. The Cumberland Enclave has these sort of deep stream valleys with fairly narrow floodplains along the Cumberland River. Some of the other rivers that come into this area include the lower part of the Obi River, and there's also the what is that up there? It's like Spring Creek and the Rolling Fork. There's a few streams that come into this, but the main one is the Upper Cumberland River.
On the Roaring River.
And what you have here, Highland, the Roaring River. Thank you. That's exactly it, the Roaring River. And what you have here then is the typical Highland Rim surface, which is made out of chert. So that's going to be the upper part of those hills that you see around. And then it's going to very steeply slope down onto these limestone side slopes. Underneath all those trees, which you can't see, probably about maybe a halfway down the slope, is the Chattanooga Shale layer. Okay, and I'll teach you to kind of expect to know about where that would be. And then you come all the way down to the floodplain where you've got sort of the Creek Valley. One of the reasons why I think this area is sort of its own place, its own kind of ecoregion, is that it's so deep and dissected that it's really lush with forest. Some of the richest forest anywhere in the south central United States occur here. Very high humidity levels, very large trees, just a beautiful, beautiful landscape, gorgeous rivers and streams. And then there's another reason, and that is that these areas have a lot of cliff faces, that, especially along the Cumberland River, these very big high cliffs that are home to about 6 or 7 species that are endemic to this region. And so that's kind of one of the things that these ecoregions often have, is they support their own clusters of endemic species. Sadly, the upper portion of the watershed has been flooded and pounded by the creation of Lake Cumberland. And that was done many years ago with the construction of what's called the Wolf Creek Dam. Back in 2010, when Nashville experienced a bunch of flooding due to getting close to 20 inches of rain in one single 24-hour period, you may remember that it was all over the news. The Army Corps of Engineers was very worried that the Wolf Creek Dam was going to rupture. And it crosses the dam, but it creates a large hamlet in the southeastern United States behind it, which is called Lake Cumberland. It's a huge area for summer visitors, lake houses and boat houses and all that kind of stuff. Okay, so let's talk about the bluegrass. We already just covered the Nashville Basin and the inner and outer basin and the Cumberland Enclave, and where you can see that is right down here. Now we're going to move over. You've got an elevated sort of plateau that separates those basins. You climb up and across, and then you drop down again into what's called the bluegrass right here, this big region. It's bordered on the east by the Appalachian Plateaus, and on the west and south by the sort of the elevated highland rim, or the Pennyroyal Plain, as we'll call it. And then up here on the north, it's bordered by what we call the glaciated plains. So it's a region of glaciation. There are 4 major sort of subdivisions within the bluegrass we're going to talk about. There's the inner and outer bluegrass, very much like the inner and outer Nashville Basin in many respects. There's the bluegrass hills, which are kind of this hilly uplifted region, not uplifted, but a hilly erosional, these erosional hill remnants in the middle of the bluegrass, kind of like the knobs of the Nashville Basin. And then on the outer edges of the bluegrass is a region called the knobs. And if you're in Indiana, it's called the Norman Uplands. That's one thing that I want to make sure you know, because you're going to see this a bit over this next hour, is 2 or 3 names for the same region. And the reason for that is that in Kentucky, they call it one thing. In Indiana, they call it another. Or in Illinois, they call it yet another term. So here, I use the dash just to kind of connect those two. The knobs dash Norman Uplands basically means the same thing. Okay. So the inner bluegrass is an area of kind of rolling landscapes, as you see here outside Lexington, Kentucky. It's an area that historically we think was mostly sort of open oak savanna or woodland. This is an area where there were scattered trees, sometimes a lot of trees, and maybe even forming sort of an intact closed canopy. But you also had enough sunlight reaching the ground that it had a grassy layer on the ground. And when the first settlers came to this area, they referred to whatever that native grass was as bluegrass, since it had this bluish appearance. Now, in truth, we really don't know what the original bluegrass of the bluegrass region was. Some people happen to think it's the true bluegrass, like you might plant in one of your lawn mixes today. Very popular non-native species from Europe called Poa pratensis. In some other cases, though, we think that bluegrass, it most certainly was a native species, because people applied the name bluegrass to this area way back in the 1700s. So there would not have been time for white settlers to bring in some non-native species and for that to get established. So in any case, then the bluegrass might have been a native species, like some type of wild rye or something to that effect. All right, so above this bluegrass layer then were a rich scattered assortment of different kinds of trees, particularly oaks like bur oak and chinkapin oak. And then many of the early settlers described this as almost like a woodland pasture, is sort of the term they used to describe the bluegrass region. To the Iroquois Indians, this area was known as the Great Meadows, and it was actually considered to be their hunting ground in the 1700s. This was an area with extensive documentation of bison in the 1700s. This was an area that Daniel Boone, the early long hunter, first observed some large herds of bison in this region, in the bluegrass. It's also the birthplace of American vertebrate paleontology, the study of animal fossils, of vertebrate fossils. Big Bone Lick State Park, which is located in the bluegrass, is home to some amazing fossil records of things like woolly mammoths and American mastodon, both of which are types of extinct elephants. There also are records here of extinct bison, as well as modern bison, and of giant ground sloths. So you can go to Big Bone Lick State Park today and see this area where these large animals sort of licked and pawed, and even they would lick the ground and paw the ground to get the salt and the minerals out of the limestone rock layers and the limestone mud that was there at the site. And of course, the fact that there was so much big game and open savanna habitat with scattered trees and abundance of grass meant that when the early settlers got there, it was already somewhat naturally open, and it was very easy to transform that landscape into a pasture landscape where livestock that European settlers brought with them could flourish. And so the beautiful, fertile, rolling landscape of the bluegrass today is known as horse country. It's a big area for thoroughbred horse breeding and racing, things like the Kentucky Derby, for example. And then in the middle of the inner bluegrass is a deeply entrenched area of where some of the rivers have cut down into the bottom of the bluegrass basin. Here you can see the Kentucky River as it sort of winds its way through. If you look off into the distance over here on the far upper left, that's the Kentucky River also, where it kind of winds back around on itself. And then these cliffs that you see here are known as the Kentucky River Palisades. And they're home to almost like vertical grasslands in many cases, that you get these very grassy ledges of species of plants. And there are also many examples, or several examples at least, of species that are more common in the West, in like glades and rock outcrops that occur on some of these cliff faces. And at places like Blue Licks Battlefield State Park, which is east of Lexington, it's still a great place for you to walk along the path of one of these ancient bison trails. We call these bison traces. So these traces, which are preserved here at Blue Licks, also site of a Civil War battlefield, are a reminder of ancient ways of life, where trails that were deeply sort of, ingrained into the landscape by herds of bison and elk and even other big animals before them. These animals would have roamed these areas extensively. And of course, these traces became the early paths and roads for Native Americans and later for settlers. Daniel Boone, the long hunter, for example, would have walked this exact path many times in the course of his life as he fled, in some cases, various incidents with various Native American tribes in the region, like the Shawnees and the Mingos and the Wyandots, and then other settlers. Many Native Americans would use these as trade routes or to embark on hunting expeditions. So these are very important, and we don't have many of these preserved on the landscape today. Most of these areas, because they were such great travel corridors, later became improved roads and trails and paths, and eventually would become paved. And the modern highway systems that we use today largely have replaced those ancient trail systems. The outer bluegrass is also home to a few intact remnant grasslands, like these limestone glades here, with beautiful purple cone flowers you see over there on the margins. And one of the common features, if you're heading west out of Lexington towards the edge of the bluegrass, as you climb up into the adjacent, what's called Pennyroyal Plain, you'll notice that you go up an escarpment, right? That's the name for this sort of line of hills. And this particular escarpment is known as Muldraw's Hill. And that's a common sort of a name for people, especially in Kentucky. But you need to make sure that you're aware that Muldraw's Hill is the escarpment that separates the outer bluegrass from the Pennyroyal Plain to the west. Now, speaking of which, this line of hills in some cases is quite knobby. And so these knobs fully encircle the bluegrass, and they continue on up into Indiana as well, across the Ohio River. And these knobs in many places are very prominent. And in fact, they call it the Knobs region. If you're in Indiana, it's called the Knobstone Escarpment, which is basically the same as Muldraw's Hill. And if you're in Indiana, they call the whole region the Norman Upland. Again, I'm sorry for all the terms, but I want you to make sure you understand how to kind of fit it all together. It is from one of these knobs that artists have depicted Daniel Boone's first exploration into the bluegrass region, which would have been in 1769, looking out across the bluegrass, then known again as the Great Meadows by the Iroquois tribe. And you can see herds of bison depicted in the meadows and the grasslands below. This landscape has not changed all that dramatically. The hills are still forested and wooded. The savanna-like landscape still exists in those sprawling areas between the hills. The biggest change is that the original grasslands that were there have been displaced by non-native European grasses. So we brought in a whole suite of invasive species to replace them. And of course, just 20 years or so after Daniel Boone first came into this landscape, bison were totally eliminated from this part of Kentucky and of course, eventually from the whole state and the whole region. So there's been a lot of ecological collapse and we've lost many of these aspects. This is a little bit farther north where you can see the Knobstone Escarpment or the Knobs region, very highly dissected here on the right and up toward the north. And this area of the Knobs then grades into this elevated plain, which is part of the Pennyroyal Plain we'll talk about in a minute. Here you can see I've got the term Mitchell Plain, and that's just sort of a part of this broader Pennyroyal region. So the high elevation here is actually in the lower left. That's where the upland tableland plateau is. And then it drops off very steeply into all these dissected hills. And the lowest elevations are up here in the upper right. This is kind of what the Knobs region looks like. Just a bunch of knobs, a definite escarpment looking off into the lower elevations there. And if you look on this map here, you can see that knob region right here. It's 71C. And up in Indiana, just to reiterate, they call it the Knobstone Escarpment or the Norman Uplands. And then once you hit into Kentucky, it's simply called the Knobs. And it kind of comes around this southern edge right here. Okay. All right. Next, what I want to do is bring in the sort of three major uplands of the interior low plateaus. We have the Highland Rim, which forms this large tableland here, kind of like a bathtub around the rim of the bathtub, which is the Nashville Basin. And that's this region right here. Then we have what's called the Pennyroyal Plain. The Pennyroyal Plain stretches mostly here and then northward up through here. So that's where that is. And then finally, the Shawnee Hills is this part of southern Illinois, and it comes over into this region of western Kentucky. We're going to talk about those. All right, let's go to the Highland Rim first. A minute ago, as I was circling things with my cursor, I may have gotten a little bit loose with my arrow. So I'm going to repeat myself one time on this. The Highland Rim is 71F, and this portion over here is 71G. It is not 71E, okay? That's the separate Pennyroyal Plain, which we're going to come back and talk about in a few minutes. The Highland Rim is divided into what's called an Eastern Highland Rim, which is largely east of the Nashville Basin. And then we'll talk about the Western Highland Rim, which includes the southern parts of Clarksville all the way down to the Alabama line to the west of the Nashville Basin. The Eastern Highland Rim can be seen here looking off from the Cumberland Plateau. You've got the Plateau Escarpment, it comes down, and then there's a relatively flat plain, which is the Eastern Highland Rim. We can look at it another way. This is instead sort of turning it around to the opposite, looking from the Nashville Basin towards the Cumberland Plateau. So I've got some features labeled here. The main body of the Cumberland Plateau is way off in the distance. That's what forms that sort of the horizon line back there, okay? But keep in mind that from this distance, which is 20 miles away, the Cumberland Plateau, if you were right up against it, is 1,000 feet high from the top of the plateau down to where it reaches the bottom. That's 1,000 feet of elevation gain. But here, looking at it from so far away, it doesn't quite look that impressive. And then on this other side, then way off in the distance here on the right side of the horizon is also the main body of the plateau. Now, what I want to draw your eyes to, though, is kind of what's happening right here up in the foreground or kind of in the distance. You've got basically these remnants of the Cumberland Plateau that still remain. Here, one of them is very small. It's just a little bump. And then you've got this larger one that is, basically a total remnant of the plateau that looks just like it does 20 miles away, except it's completely disconnected. All right, so these are referred to as erosional remnants. And they have all the same layers of the main plateau body. They have a sandstone cap and then a lower limestone level. But basically, that's the plateau, just far removed. We're going to explore later how that process of erosion happened, which resulted in that separation. But the highland rim then is what you see all around that. That's the flat tableland here, all around it, which is quite flat to gently rolling in places. And then as we get to the edge of the highland rim, it drops off as the eastern highland rim escarpment, and it drops off into the Nashville Basin, specifically the outer Nashville Basin. And just to reiterate here on the geology, the top of the highland rim up here at the very top is all underlain by a very hard chert rock. And then as you get off onto the escarpment and down into the basin, they have softer rock types, especially limestone. Any questions about sort of the separation between those ecoregions here in this view?
Is Short Mountain the name of that mountain, that erosional plateau piece?
Yeah.
Or is it a term?
It's a term, it's the actual name for that one specific mountain. Yeah.
All right, next.
Let me ask you a quick question here. Why is it that in the escarpment region here, why is the bottom sort of 3/4 of the slope all open, but the top is forested? You see how we've got that pattern? What can anybody speak to that? Sarah, what do you think? I'm gonna call on some folks here from time to time.
The only thing that's coming to my mind when I think about it is the top is a little less eroded compared to that part, so maybe it has something to do with the type of rock that's there or the erosion that happens.
That's a great point. Yeah, that's a really great point. In fact, so the limestone typically erodes to leave us very smooth surfaces. Okay, so gently sloping, sometimes steeply sloping hills that have a very regular kind of smooth contour. Like take a look, for example, down here in the bottom of the valley. You see how smooth and sort of convex these lower slopes are? That's all over limestone. But just as you pointed out, by the time you get to the top of that hill, there's a cap of chert. And that makes it very erosion resistant. And it means that that's really it's steep and it has lots of rock ledges, but it doesn't erode as easily. And because of that extra steepness combined with that different rock type and soil type, it also means those soils aren't nearly as fertile as those lower down. So for early settlers coming into this region, they cleared a lot of those slopes. They deforested them by extensive logging. And then many of those slopes were converted to cornfields even. My grandmother, who died in 2020 and was born in the 1920s, I remember her telling me that, my great-grandfather used to plow those side slopes with mules and a hand-drawn plow. So they would go side to side on those slopes. There was a common joke about Tennesseans in the 20th century was that most native Tennesseans had one leg longer than the other because they were so used to walking on the sides of hills. We were called hillbillies, right? And so when you were walking on the side of the hills, plowing these hillsides, one leg was obviously a little bit shorter than the other, kind of walking unnaturally there. So yeah, a lot of these were used for agriculture, and then later, many of those slopes eroded extensively, causing massive problems of soil erosion. And today, many of these areas have been improved by planting non-native pasture grasses. And so most of these areas today are used for cattle grazing. All right, now the Eastern Highland Rim, we'll look at in another view here. You can see in this sort of three-dimensional view, you can see what we were just talking about, that chert layer right here over on the right, and then the limestone layer down below. Notice that heavy black line here, which is, what is that again? Kiki, what is that heavy black line here? It's about 10 feet thick.
Oh, I don't remember.
Okay. Anybody else? Matthew?
Is it shale?
It is, yes, the Chattanooga Shale layer. Good deal. Who gave me that answer?
It's Juliet.
Juliet, excellent. Thank you. That's the Chattanooga Shale layer. Very good. And again, that's the technical dividing boundary between the Nashville Basin and the Highland Rim, is that specific shale layer. Good job, Juliet. Okay, I have drawn in here Short Mountain, where you can see that it is very isolated from that main body of the plateau. Again, we'll explore later how that came to be, because that's actually quite a cool story. This is another view looking from Google Earth. Sky view looking down, you can see the plateau off to the right, the Cumberland Plateau, and the Eastern Highland Rim is that largely cleared space that you see. And from this, then, the Highland Rim has some areas that are very fertile and very good for agriculture. That's especially evident here on the right side. All this area down here, kind of at the foot of the Cumberland Plateau, has soils that are very deep and very fertile. It makes it a very productive region for things like corn and soybeans and cotton. But the other, the western part here, closer to the Nashville Basin, is generally not suitable for agriculture for a couple of reasons. Number one, it's parts of it are really dissected. You can see here, for example, some of the rivers that are crossing it, and they cut down and it makes it too dissected. But then another reason is that parts of this area are, the chert layer is so close to the surface that the soils are very poor, very acidic, and they also are very waterlogged for parts of the year. So it has a lot of, it has a clay hard pan underneath it and makes it not conducive to good agriculture. For that reason, then we would expect to see different ecosystems in these different parts of the Highland Rim. What do you suspect, just looking at it, what do you think the original condition of this area was here that is now suitable for agriculture? What type of ecosystem would have been there in those areas of fertile soils?
Grassland.
Yeah, I mean, that's emerging now, but that wasn't always the case. It wasn't always thought to be the case. As recently as when I was in graduate school, I was taught that that entire landscape was historically forested. But the very original accounts by the first explorers and settlers and hunters that came through this area all testify to the fact that this was mostly a grassland region. But not everything's grassland. Those dissected areas over to the left, down in some of the ravines, that was an area where you definitely expected forest. So this brings to mind what we call sort of the two divisions of the Highland Rim, the Eastern Highland Rim. There's the undissected part, which is flat to rolling, mostly historically grassland, lots of wetlands as well, especially some swamps in places. But then the dissected Eastern Highland Rim is mostly a forested region where some of the rivers that cross Middle Tennessee, like the Caney Fork and the Duck River and the Elk River, as they begin to sort of originate and cut down into the Nashville Basin. Here's another look at this from a topographic map. You can see that large area over here, sort of the dissected versus undissected Highland Rims. You can also see the plateau escarpment off at the far right, where those sort of dense contour lines are that signify those steep slopes. And then out through here, you can see all this area that's very clear. That was a region that was, today is all agriculture, but historically was mostly probably open prairie. Now, I mentioned that there's a big area that is not suitable for agriculture, and this one was selected in the middle 1900s to become an Air Force base. And in fact, it's called Arnold Engineering Development Center, sometimes called Arnold Air Force Base. 50,000 acres here, largely a big block today of forest. In this region, if you look on the maps, though, there's something about this area that most people know it as a particular name, and it's called the Barrens. You can even see it today on these modern maps, the Barrens, the Barrens. That's actually a name that goes way back deep into the 1700s. The first early settlers who came to this region, because these areas had such poor growth of trees and mostly were in grassland, that was the term applied by the very first settlers, was called barrens. They didn't call forested areas barrens typically, but any area that had very poor growth of trees, it could be a rocky glade, it could be a savanna, it could even be a really open woodland that had very bad tree growth or stunted tree growth, or it could be a wide open prairie. They kind of use that term barren somewhat broadly and without distinction. Here's an overview aerial photo of Arnold Air Force Base, probably in about the 1940s or 50s. Again, very flat landscape. And a lot of this landscape, again, is so flat because that chert layer is only just a few feet below the surface. And there's a clay hardpan above it, which keeps the drainage very poor, which means there's a lot of wetlands as well in this landscape. And you'll see that on a lot of the topographic maps. Places like Sinking Pond is a giant swamp forest, about 600 acres in size. That's shown up there in the upper right. But then also a lot of these ponds are naturally open and they have more of a marsh vegetation. So mostly dominated by grasses and sedges and wildflowers, what we call forbs, F-O-R-B-S, forbs. And those emerge up out of the water. Marshes and swamps are both pretty common features here on the Eastern Highland Rim. Then there's the barrens, which are the grasslands kind of in the strict sense. And there are some places where these grasslands still exist. Unfortunately, they've been eliminated by about 99% of their original range. There are some places, though, preserves that are being managed with prescribed fire where these grasslands can still be seen. And this is a painting that actually was produced this past year by a good friend of mine, Philip Juris. Actually, last Wednesday, we went to the University of the South at Sewanee to see his art exhibition. And one of the reasons I'm not with you guys today is one of the members of our party tested positive for COVID the next day. And I don't know if I've got what he's got or not. I'm feeling just a little bit under it. But so we went there to view this painting and about 50 others. And this shows what the barrens would have looked like in about the year 1800. Before white settlers moved into this area, at a time when this was still the hunting ground for the Cherokee. And you can see those beautiful grasslands extending out, scattered trees. So there were some savannas as well. And then off in the distance, tell me what this, what is this feature that we're looking at far off in the distance here? Ryan, do you know what that is? This will be looking southeast across the Eastern Highland Rim, looking southeast.
I think he's responding on the chat.
Oh, got it. Okay, no worries. Let's see what he says on the chat here. Cumberland Plateau, great job, Ryan. Yeah, that is the plateau, and the that leading edge that you see there is the plateau escarpment. Good job. Thank you, Laura. Now, a lot of the parts of the Eastern Highland Rim also have extensive woodlands. Some of these are natural woodlands. Some of these have become more wooded over time as forest has displaced grassland. But these beautiful woodlands, they go from very wet to very dry. This is what we call flatwoods. And part of the reason for that is that there's a clay hardpan that's down about maybe 2 or 3 feet below the surface. And that bed pan that's under there, what's called the hardpan, in times when it's wet, water cannot drain through it. And so the soil above the hardpan becomes very waterlogged. Sometimes it's so waterlogged, in fact, the trees will actually tip over with their root systems. They'll just completely upturn, and often during windstorms as well. And then during the summer and the fall, it'll become so dry that it gets totally desiccated, and it's just so bone dry that oftentimes it about the only thing that can grow there are grasses. And then those grasses also make it very conducive for fire to burn through those open woodlands, keeping them open. So flatwoods are an important part of the Highland Rim ecosystems. As I mentioned, there are some areas, though, that are deeply dissected, such as along the Caney Fork River here that drops off of the Highland Rim down into the Nashville Basin. And here we have a very unusual type of ecosystem where the flood of the river sometimes swells up and covers these rocks adjacent to the river. This is a type of ecosystem called river scour, and I'm going to put this in the chat box. We're going to come back and talk about it, later in the class as its own ecosystem. But I wanted at least to point this out so that you'll see it. Back in about 2018, I had a graduate student who now works for the Pennsylvania Natural Heritage Program. And for the class project, I assigned the students to go out and study a particular plant of their choosing. I gave them a little, guidance that we thought was had never been described by scientists before. And so my student, Claire Chiffre, went to Rock Island. She was particularly drawn to this place, Rock Island State Park. And while she was there, and out here on these little pools of water on the limestone bedrock, she found a small grass-like plant that we call a sedge. And then she ultimately determined that it had never been discovered before. It was totally new to science. And then she graduated from Austin Peay with her master's degree and went on a couple of years later to officially name that new species. And it's now known from about 7 places in the world, including a couple places in Arkansas, Missouri, 1 site in Alabama, and 2 places in Tennessee. So just a cool example of how sometimes the projects that you guys get involved with in the classroom actually lead to discoveries that then can lead to research and publications. And that's just one really neat example. So these are Rock Island's a great place. I encourage you, if you love swimming and exploring and hiking, seeing cool species, a great place to visit. You must be careful though, because they do release water from an upstream dam. And sometimes when they blow those alarms, you need to make sure you get out of there because the water levels can rise very, very quickly. Another place that's a part of the dissected Eastern Highland Rim is Burgess Falls State Park over near Cookeville, Tennessee in Putnam County. Here, this gorgeous waterfall drops off of the Highland Rim into the Nashville Basin. And you can actually see that exact geologic boundary between the 2 physiographic provinces here. Notice it's at this point right underneath that cliff line where the very hard rock layers of chert above it give way to a shale layer. And you can see where that shale is sort of eroding out from underneath that cliff line. And that's why there's a little recess there that's about 2 or 3 feet deep. That very thin shale layer is quickly eroding out. So what happens over time then is as that shale comes out and is washed away, then the heavy overlying chert eventually becomes too heavy to sustain itself. And part of that cliff face just breaks off, right? And then you get these boulders that tumble down. And so through the process of millions of years, you can see then how eventually that waterfall is going to erode farther and farther back upstream. And that's a process that's called head cutting. And I'm going to put that in the chat as well. Head cutting, also known as headward erosion. So that's a process by which stream valleys kind of can form. And these waterfalls oftentimes are the places where that erosion is taking place the fastest. Here on this waterfall, you can actually see that there's like a tongue of rock that sticks out, sort of this triangle. And that's that very erosion-resistant chert layer that is just fighting against erosion because it is so hard. A lot of the waterfalls on the Highland Rim occur at that contact zone where that chert layer is being rapidly eroded. And so that's why the waterfall is there in the first place, is because you've got that very hard rock over top a very soft, highly erodible rock. Many of the waterfalls in that region, like Cummins Falls, and Short Springs or Machine Falls at Short Springs Natural Area. They all occur on that same line. Okay, let's jump down now and talk about the Molten Valley, which is at the southernmost end of the Eastern Highland Rim. And so as the Highland Rim comes down, here's Huntsville, Alabama, about right here. You cross the Tennessee River, and then there's a little line of hills. This is Ecoregion 71J. That's a J, by the way, and not an I. And then notice that there's a little bit of an entrance way into the valley on the eastern end between the Cumberland Plateau and the Little Mountains. And if you sneak into that little opening, which is only a couple miles wide, then that opens up this this fairly long valley. It's about 50 miles east to west and about 10 to 20 miles north to south. It's called the Molten Valley, named for the town of Moulton, Alabama, which is right in the middle of it. This valley is important, and it's different from the rest of the Highland Rim because it has an abundance of limestone right at the surface. And this limestone forms these open glades where there's open bedrock either at or just under the surface. Here, you can't see a lot of that open bedrock, but it's only about 2 inches below the surface. And where it's very shallow, it means that trees cannot grow there. And you have these grasses and small herbs. And then the deeper soil units are back in here where you see all these trees, where the soils can be 25, 30 or more inches deep. A lot of these glades have endemic species, which are totally unique to the Molten Valley and occur nowhere else on Earth. They're entirely limited to just a 3 or 4 county area of Northwest Alabama. Prairie Grove Glades Nature Preserve in Lawrence County, Alabama is a great place to see these unique ecosystems. It's a place that's owned by the Nature Conservancy. And then the Little Mountains is that little unit here I just mentioned that's to the north of the Molten Valley, south of the Tennessee River. This is a really cool area. And it's kind of funny because if you're in northern Alabama, a lot of people say, yeah, I like to go deer hunting up on the mountain, or my grandmother lives up on the mountain. But they're not talking about mountains in the sense of like the Great Smoky Mountains or the Rocky Mountains. They're basically talking about a hill, which is really no different than some of the hills we see around Nashville or even Clarksville. But in northern Alabama, at least in that part where it's very flat on the Highland Rim, you know, if they want to call it a mountain, we'll let them call it a mountain. But just know that it's really not that dramatic. But they call them the Little Mountains. And here, this is a topographic map. You can see the Tennessee River is flowing here from east to west. Here's Athens, Alabama. Here's Florence, Alabama over in the northwest. And then this is all called generally the Tennessee Valley. But then here's that Molten Valley down here, that cleared area. And then the Little Mountains runs east to west, just north of the Molten Valley here. And to help you make sense of this, it's important that if we kind of start at the Tennessee River up here, and then let's imagine we're walking straight south, okay? First, as we come up off the river, we encounter this sort of bluff right along the river's edge. And that bluff line is mostly forested. And as soon as we climb up maybe 50 feet, we're on top of that bluff. So it's not a very high climb. And then we've got a long sort of flat plain about 10 miles wide. It's all agricultural land today. A lot of cotton and a lot of corn. But then we get to the edge of the Little Mountains, and it's a pretty dramatic little rise of mountains. There's an escarpment there. It's highly dissected in that region, lots of hills and canyons and, you know, very narrow valleys. And as you get on top of that line of hills there, then things begin to sort of gradually slope into the Molten Valley. And you cross this sort of wide plain. And when you get to the southern edge, guess what? You have another escarpment. And this one is the Plateau escarpment, or the Cumberland Plateau. And as you climb that escarpment, you climb up onto the dissected southern plateau, which we talked about earlier. I know it can be confusing because we have so many different landscapes. They're all so diverse. They're all blessed with so much biodiversity. But I wanted you to kind of have a picture of how those all kind of go together. Any questions about that before we explore the Little Mountains for a minute? Okay, who can tell me, just from looking at this, what is the geology of the Eastern Highland Rim? Again, this flat land here. Kian, do you remember?
No, I don't. Not right now.
Okay. Let's see, Brandon. What's the geology of the flat Eastern Highland Rim surface?
It'd be like sedimentary rock, like sandstone and such.
Okay, it is sedimentary and it is a hard one, like sort of like sandstone, but not that one. We were just talking about it with those waterfalls. It's the same layer. So this is all chert right here. Okay. And then when you come south of that, everybody, then you got an escarpment. So a line of hills. And in this case, the reason we have those hills standing up above that flat plain to the north is that they are another kind of hard rock. In this case, to Brendan's point, the Little Mountains geology is mostly sandstone dominated. Okay. And then you taper off, you slope down across this basin here, which is the Molten Valley. And that's the mostly limestone area we said where like Prairie Grove Glades is located. And then when you hit this plateau escarpment over here, you climb a limestone slope up onto an area that's capped by more sandstone. So I want you guys to kind of get familiar with these areas. Right now, we're just kind of introducing you. So I don't expect you to, hang on to a lot of this content too tightly, but I want you to be thinking through it as we go. Here's a close-up view of the Little Mountains. Again, the Tennessee River valleys to the north, underlain by chert. Then you've got this more elevated area of mostly sandstone that caps the tops of these hills. But just notice how deep those ravines are. And we can zoom in on that a little bit more. Very deep, fairly high slopes, for this region, really protected ravine systems. Like imagine this ravine over in here, for example. You've got to get into this ravine from the northwest and you can walk up it, kind of turning around, completely going back to the north, then it goes to the east. It's all down inside this deep protected forested canyon. So imagine then what that natural ecosystem should be. What would you expect for, well, I've already said it, forest. But in particular, you expect in these areas to have the deeper and the sort of more protected that ravine is, or that canyon. That's where we often expect the obligate forest species to occur. Species of trees and shrubs and wildflowers or ferns and certain animals that must grow and live in closed canopy forest conditions. So it's not a surprise here that we actually find some northern trees like the eastern hemlock reaching its southernmost end of its distribution. And we also have things here like sweet birch trees, for example. Both of these are species that are much more common in Pennsylvania or Michigan, but definitely rare in northern Alabama. And what makes these trees particularly at risk now is invasive species like this small insect, for example, called the hemlock woolly adelgid, which is devastating hemlock populations across the east. Within just a few years of being preyed upon by this insect, they rapidly kill the trees, and whole forests that are dominated by these trees die. Sweet birch is also at the end of its range, at the southern end of its range. So factors like climate change directly threaten these more northern species as well, because as we have warmer temperatures, more 90-degree days, these species are less and less well adapted to these humid, hot southern climates, and they're at risk of being eliminated. As you come up and over the Little Mountains, which again is just nothing more than a sort of a broad range of low hills, historically those mountains on the top and then on their southern end were much more open and grassy. And that's because they were fire maintained. That sandstone surface was made them very open. You can actually see this photograph from the 1910s sort of showing open shortleaf pine woodlands with an abundance of grass on the ground. In some places, that sandstone crops out and is exposed, forming these sandstone glades. And you can see one of these here. This happens to be an undescribed glade ecosystem. No one has ever studied this from a vegetation analysis perspective. We didn't even know there were sandstone glades in the Little Mountains until he's a now famous guy named Kyle Leibarger, who established the Native Habitat Project. He's all over TikTok and YouTube, but he brought this to our attention, sort of to the world. Just a quick shout out. How many of you here have heard of Kyle Leibarger and the Native Habitat Project?
Me.
Okay, there's one. I know Laura has. Maybe put it in the chat box if you've heard.
Me.
If you've heard of Kyle Leibarger, put him in the chat box and say, yeah, I've heard of that guy. Anyways, he is absolutely famous now. He's been, all over the TV, and he's got like 1.5 million TikTok followers, something crazy like that. But he's a great force for conservation and talking about nature. He was just a guy during the pandemic trying to make a difference and shooting videos. And, and now everybody and their grandmama knows about Kyle Leibarger and the good work he's doing. Here's Kyle there, and you can click on a little video here, which I'm going to do just to kind of show you some of the work that he does and the kind of outreach he does. Hopefully you'll be able to hear this.
All right, so I'm here at the partial sandstone barren or glade, and this is a really cool ecosystem.
Can y'all hear that real quick?
Yep.
All right, let's keep playing it one more time. Go back. Right there.
So I'm here at the partial sandstone barren or glade, and this is a really cool ecosystem I talk a lot about during the summer when a lot of wildflowers are blooming here. And we just got a grant for $8,000 to start turning this place into an outdoor classroom. And this is right next to the school that I actually went to. So you see all these boulders here behind me. Well, they put a sewer line in right here back in the day and took out a lot of rock. And this is a giant pile of rock now, even bigger pile of just dirt and debris. I'm hoping to use these as benches and just sit them around the hiking trails out here so students can sit on them. And you see all this exposed sandstone, it's actually buried under a lot of this. So by removing this dirt, we can expose a lot of the original sandstone barren here. And the reason these places got trashed or destroyed so often is because back in the day, people just looked at this as wasted land. They thought they couldn't do anything with it, but it actually has a lot of really unique species that grow here that can't grow anywhere else. And so the rest of this place that's not under a power line looks like this. It's all now covered up in privet and other invasives. But we're about to bring this place back to life.
So Kyle Leibarger is an incredible force of conservation. I definitely encourage you to, check him out. I think he's got loads of videos and content, and just a great force for nature and for conservation. Awesome. Let's just see who all is here. Yeah, so Corley says, yes, I am repping SGI in one of his videos. Go Corley. Awesome. Matthew, I've been following him on TikTok for about 3 years. Tremendous. James says, I've heard of his project, but not the research. Awesome. Go Kyle. Yes, me, says Jody Elliott Morgan. Great. Ryan says, I think I've seen some of his TikTok videos. Kian says, yes. Brandon, I have not. All right, great. This is awesome. Kyle will be glad to know that we covered a little bit of his work here in my class. Another place in the Little Mountains, again, these are kind of not that dramatic, right? But they can be quite beautiful landscapes. This is called Cane Creek Canyon Nature Preserve. This is actually a privately owned nature preserve. In fact, you guys will be shocked probably to learn, I forgot to make this connection. The guy that wrote your textbook owns this nature preserve, Jim Lacefield. And I know, Laura, you just got your book, I think, or Jody won, and he signed it for you, right?
Yes.
Terrific. Jim Lacefield's an amazing person. He's got a doctorate of education. He's phenomenally gifted as a geologist and an educator, but he also is a very good force for conservation. This preserve is, I don't know, probably about 1,000 acres, at least several hundred acres. And he often has groups that come and visit. It's a gorgeous place. There are these rock houses that we talked about briefly. One of these rock houses here at Cane Creek Canyon is really significant. It's got these beautiful forests down below it. Obviously, really important sites again for Native Americans. But one of the species that grows underneath the rock overhang is called French's shooting star. And if you can see the entire worldwide distribution of this species here from Arkansas over into Kentucky, and it does occur about 30 miles north of Clarksville in the Shawnee Hills region, which we'll talk about in a bit. But notice that it jumps all the way across Tennessee completely and does not occur in Tennessee. And then it's found at Cane Creek Canyon Nature Preserve underneath just this one sandstone rock house feature. It brings to mind, how did this thing get around? How does it move from one rock house to the next? That's a topic we'll explore later in this class when we start sort of connecting these various themes of evolution and biogeography into this class. Okay, let's take a break, and we come back. We're going to talk about the Western Highland Rim. We'll get up into the Shawnee Hills, and then hopefully we'll get into the coastal plain, begin the coastal plain in our last hour. All right, gang, 10 minutes, come back at 6:57. Thank you. All right, everybody, I'm back. See, give everybody a few minutes here or a few seconds to get back in. Any questions about any content so far? Hopefully with this section, you'll see that the main thing I'm trying to show you guys is sort of how diverse the landscape is, and kind of beginning to make that first step at connecting ecosystems and habitats to these various landscapes, and making sure you're kind of thinking about things in that respect. And then of course through that, we're basically connecting the geology, which is how we started, with not only the landforms, but ultimately the geology to the ecosystems. And that's a real key point here. Okay, we're gonna proceed here with our final hour of now rolling up through the Western Highland Rim. So kind of where we left it was the Little Mountains down here at the far south. And then notice again, we have the Tennessee River, and then most of what is north of the Tennessee River in Alabama, and is part of the Western Highland Rim. There's a little bit of the Eastern Rim, which kind of extends across both sides of it. The other thing that I want you to notice here are all these rivers that cross the Nashville Basin. Let's name those real quick here from sort of north to south. Up at the north here, we have the Cumberland River that comes down out of Kentucky. We talked about the Cumberland Enclave, right? We showed you the Caney Fork River, where Rock Island State Park is located. That's here. Then we have the Stones River coming in, and the Stones originates at its very upper end, kind of at the escarpment of the Eastern Highland Rim with the Nashville Basin. You have the Harpeth River shown here, which totally originates within the Nashville Basin and flows into the Western Highland Rim. You have the Duck River next, which starts on the Eastern Highland Rim and drops off, crosses the Nashville Basin, and then crosses the entire breadth of the Western Rim before joining the Tennessee River over here. And then down to the south, you have the Elk River, which actually does something that few of the others do. It originates on the Cumberland Plateau, drops off, or actually at the base of the plateau on the Plateau Escarpment, crosses the Eastern Highland Rim, drops into the Nashville Basin, and then enters the Tennessee River down here. You'll notice then the Western Rim is kind of just to the west of the mouth of the Elk River down here. Once you get into the Western Highland Rim, then it goes north all the way up to where Clarksville is. And so you can recognize Clarksville because it's right here at this bend in the Cumberland River, which comes around. And then this is the Red River here, which enters right there downtown on Riverside Drive. And so really Austin Peay State University is located kind of at the boundary between two ecoregions. From the university south, like down on Riverside Drive and the southern part of Clarksville, like around Ashland City Bypass, that's all part of the Western Highland Rim. It's kind of up and down, very hilly landscape. But then when you cross the Red River, especially, and you get up going toward Wilma Rudolph Boulevard and up toward exit 1 of the interstate or out toward Fort Campbell, then you're on a region called the Pennyroyal Plain, which is the next region we'll talk about after the rim. Finally, the Western Rim turns and goes all the way up through land between the lakes, all the way almost to the Ohio River. So there's kind of a northwestward extension. And then it does cross the Tennessee River into West Tennessee, just along the easternmost portion of West Tennessee is part of the Western Highland Rim. All right, so some towns in the Western Rim would be cities like Dixon and Hohenwald, Dover, Waverly. These are some, and Centerville. These are some towns that are common in the Western Highland Rim. Ashland City is kind of in the Western Rim as well. Now, as I mentioned earlier, one of my former students, Sonny Fleming, and I have sort of been updating the ecoregion map for Tennessee, and the Western Highland Rim is one of those regions that needed some updates, particularly because there are some areas that are highly dissected, and then there are areas that are not very dissected, kind of flat. And so one of the key changes that we have sort of brought to this region is the recognition of those two. So for example, here in our updated map, we recognize the dissected Western Highland Rim, which is more common. It makes up the vast majority of the area. It's very hilly and rugged and dissected. But then these areas in green that you see, particularly around Dixon and Montgomery Bell State Park, or farther south near Lawrenceburg, these are the undissected Western Highland Rim. And this is important because these two areas are very different from a historical ecosystems perspective. Let's focus first on the dissected Western Highland Rim. This is down at Cheatham Wildlife Management Area in Cheatham County near Ashland City. The river you see in the foreground is the Harpeth River with its cliffs, beautiful rugged hills, deep hollows and ravines, mostly a forested or heavily wooded landscape. This is Land Between the Lakes National Recreation Area. On the right, this is the Tennessee River, and then you have the Cumberland River that comes around here. And then this land in between, called Land Between the Lakes, is the roughly 10-mile wide zone. It's very hilly and very dissected as well. This is another view kind of turned the opposite direction from north to south. You can see the LBL region there. A lot of cool stuff in Land Between the Lakes, extensive forest, extensive woodlands, but there's also historically was a sort of a sliver of savanna that ran up and down the middle of the ridge that sort of this watershed divide, this dividing ridge that runs north to south. And in some places, particularly up on the Kentucky side, this was more of an open, sparsely treed grassland, open woodland. Historically, bison and elk were very common. And the U.S. Forest Service, who now owns and manages LBL, has introduced a herd of elk and bison at what's called the elk and bison prairie. It's not a prairie in the sense of how we're going to define a prairie in this class. It's not an open treeless landscape, but rather it's sort of an open rolling grassland with scattered trees, which is what we would typically call a savanna. You can actually see the elk and bison prairie right here on this map. And it's a great area. It's probably a road that goes through it. It's paved, maybe 5 miles. You can pay $5 or so and take a ride through the whole thing. It's great. There's some educational exhibits. You can actually stop and get out of your car, except of course when the bison are right there. But it's a great place to see two large mega herbivores that you rarely can see anymore, both bison and elk. The Natchez trees.
Sorry.
Yeah, go ahead.
I'm sorry. Back on that view of the Cumberland and the Tennessee River.
Yeah.
It intrigues me that they're such two big rivers so close. And is there evidence, or does anybody ever think that they were one river at any time flowing together there, or?
No evidence of that. We're going to explore that more deeply later because these are fairly recent rivers in this region. So the rivers themselves are very old and ancient, but we're gonna explore over the next few weeks some of the evidence for why these rivers in particular were in different places, say 2 or 5 or 10 million years ago.
Okay.
So hold on to that. I love what you're thinking and where you're going, but yeah, these have been always pretty well separated, that we're pretty sure.
All right, thank you.
Well, back to a certain point, in which case then their ancestral rivers that were before them would have existed in different places, I might add. Okay. And that's a good point, Laura, too, that brings up is that, where we have these current river systems, sometimes those rivers are very ancient, very old. Like the New River of Virginia, for example, is thought to be tens of millions, maybe over 100 million years old in the same place, more or less. Other river systems like the Cumberland and the Tennessee have fluctuated in their channels over time. And in some cases where we now have a river that's flowing south to north, like the Tennessee here, if we go back to the, say, Pliocene or the late Miocene, we probably had rivers that actually ran east to west in a completely different arrangement. So we'll explore all that in coming weeks. The Natchez Trace Parkway is, the northern section of it is on the Western Highland Rim. You can see it here. It goes all the way down into Mississippi. But this portion that's up here from about where the old Trace Drive is all the way up to Nashville is on the Western Highland Rim. Then as you get farther down toward Colbert Ferry, about where the Alabama line is, in south, it goes into the coastal plain. So it's a really nice kind of a transect. This trail, which is today, of course, a paved highway, you can drive it, you can bicycle it, but historically, this was an ancient mega herbivore trail, a trace, where mammoths once walked and bison once roamed. So this is yet another one of these very ancient roads or trail systems. It was a path for Native Americans. It became an early path for white settlers. And then we paved most sections of it today. The other parts of the dissected Western Highland Rim, there are a few deep canyons, like Rattlesnake Falls is a beautiful hollow down in Murray County, Tennessee. This was actually the place I studied for my undergraduate research project back in 1998, 1999, and about 2000. And I published this study of, I studied all the plants of this canyon that is below this waterfall. Narrows of the Harpeth State Park, very beautiful over in Cheatham County. High sandstone cliffs with, high limestone and chert cliffs with some siltstone as well. Some of these are easily carved, hopefully not by modern day people. But on some of these, you can actually find some Native American carvings in the rock and some paintings as well. Then there's Courthouse Arch Natural Bridge, one of the cool features down in Wayne County, Tennessee. You can see some of the cool rock features. There are very few natural arches in anywhere in Tennessee outside the Cumberland Plateau. In fact, this is the only one I'm aware of that's west of the Cumberland Plateau. And then up on the undissected Western Highland Rim, you have open, fairly rolling to flat landscapes where the chert layer is intact. It's that Mississippian-aged Fort Payne formation that we talked about a couple times, the same rock formation that underlies the Eastern Highland Rim. And because of that, you expect that chert layer to be, it erodes into a very acidic soil. In some places, it has a hard pan, and so you can get that dramatic fluctuation between wet and dry. And in places, this was mostly grassland, we think, a mixture of open prairies and scattered oak savannas. And then as it begins to get into the more dissected Western Highland Rim, where the hills and slopes, it gradually got more wooded and more forested. Here's the beautiful little remnant, sadly, in Dixon County, Tennessee, which is no longer there. A lot of these remnant grasslands have disappeared. We've experienced more than 90% loss. In fact, actually more than 99.9% loss of these ecosystems, which means they're exceedingly important. The portion of the Highland Rim, the Western Highland Rim that's over here along the Tennessee River, near West Tennessee, is often referred to as the Western Valley. Some people have even treated it as its own ecoregion or as its own sort of physiographic section. The Western Valley is that particular part. And one reason why it kind of stands out is that it is one of the areas of the state that has a heavy abundance of Silurian aged rocks, particularly this sort of reddish colored Silurian limestone. And I don't know that it requires its own ecoregion designation, but it certainly is important from a historical context to be aware that this is called the Western Valley of the Tennessee River. It's that part where the river turns north out of Alabama and enters the Ohio River, and that's the part. In the Western Valley portion of the Western Highland Rim, there are some really key public land units, like the Tennessee National Wildlife Refuge and the Duck River unit specifically, is an area that is along Kentucky Lake. There's lots of ducks and waterfowl that migrate through this region. They specifically, as a National Wildlife Refuge, are really trying to promote waterfowl, in particular, the migrating waterfowl. There's a variety of state parks like Mousetail Landing State Park in Perry County. It's got some really beautiful views of the Tennessee River. There's some really great small natural areas too, like Carroll Cabin Barren State Natural Area. It's a few hundred acres, and it's got these exquisite old growth limestone barrens, which is these old growth grasslands with scattered old growth red cedar trees that each are about 200 or 300 years old. A lot of fossils in the Silurian bedrock that you see eroding at the surface here. This is a type of landscape that we would call a barren. And again, we'll kind of introduce that term broadly here and come back later and define it. But essentially, when we say this is a limestone barren, that's different than saying this is an area of the state called the Barrens, like we did over there on the Eastern Highland Rim. Here, we're talking about a barren as a type of habitat type or an ecosystem. When we say the Barrens, we're talking about a specific place, a proper noun, which is different. Sometimes those get a little bit muddy. And so later when we go through a review of different grassland types, we'll clarify all that so that you have a better understanding of what we mean by barrens or glades and savannas and prairies. It can get a little confusing. So right now I'm just gonna kind of hit the highlights. There's some amazing cliffs along the Tennessee River like these at Ladyfinger Bluff, which is the property that's owned by the Tennessee Valley Authority. They have what are called small wild areas. These are publicly accessible. They've got a beautiful trail system that's an awesome place for a weekend hike. Also notice that on the top of this cliff, you've got some old growth trees. These ancient red cedar trees up here, some of them are sort of twisting off the bluff face, are undoubtedly 400 and 500 years old. Okay, so we've covered the Western Highland Rim pretty well. And now let's cover the region that, that encompasses the northern half of Clarksville, northern Montgomery County, most of Fort Campbell. And then this is the what we call broadly the Pennyroyal Plain. The Pennyroyal starts over here in westernmost Kentucky, kind of near Paducah, and sort of curves down into northwestern Middle Tennessee, southern Kentucky, curves over here to about where Bowling Green is and Mammoth Cave National Park, and then continues on north up through Elizabethtown, Kentucky, crosses the Ohio River into Indiana, and goes all the way up almost to Indianapolis, up near Bloomington, Indiana. Now, the Pennyroyal Plain across that broad region is sort of divided into three sort of natural units. The part down here in Tennessee and Kentucky from Bowling Green west is called the Pennyroyal proper. That's just sort of that's what and a lot of people around here, in fact, old timers will call it the Pennyrile, or with the word Pennnyrile. Just up in Kentucky, for example, is the Pennyrile State Park. But that kind of is named a name that really fits here in this particular localized region. The other division of the Pennyroyal Plain is called the Elizabethtown Plain. And this is really found up here north of Mammoth Cave National Park, around Horse Cave, all the way up to Elizabethtown, just to the western outskirts of Louisville here. And it stops at the Ohio River. And then what's called the Mitchell Plain is the term used for it up in the Indiana portion on the north side of the Ohio River. Now, in general, the Pennyroyal is not always easy to separate from some of the surrounding regions. Like, for example, if you're out here in north of Nashville, the dividing line between what is the Pennyroyal Plain and the Eastern Highland Rim up in Sumner County, Tennessee, is not always that evident. So generally speaking, here's sort of the main difference. The Pennyroyal Plain proper, and when I'm using that term now, I'm using it for that entire region that includes the Elizabethtown and Mitchell Plains, is underlain mostly by limestone that is very prone to sinkhole development. So it's a karst plain. And what that means then is there's lots of caves and lots of sinkholes. Remember, the Highland Rim, though, is underlain by what type of rock at the surface? Somebody remind me of that. kind of rock is underneath the highland rim surface? Jacob? All right, Ryan's got it. He says chert. Good job, Ryan. It is chert. And because of that, then the geology and the soils are very different between the highland rim and the pennyroyal. The pennyroyal has a lot greater fertility. That means it's a big, important agricultural area. A lot of the highland rim is not so much. It's very acidic and very infertile. And also, the portions of the highland rim that are relatively flat don't have a lot of like up and down sort of karst features like that rolling landscape. Here's what I mean by that. If we look at the pennyroyal, this is a typical scene from southern Kentucky, kind of just north of the state line. And you can just see how up and down it is. It's pockmarked with sinkhole formations. Theo was asking the question of where does that name pennyroyal come from? And we think it comes from the little wildflower called the pennyroyal plant, which is Hedioma pelagioides. We don't really know exactly if that's what it's tied to, but that's kind of what we suspect. Notice how some of these sinkholes that you see out here, which cast these shadows, are dry. There's a cave system under that. There's a cavern under that that is collapsed. And then some of these sinkholes actually become clogged or with a sort of a clay plug, and they actually can form wetlands that will back up and form sinkhole ponds. And a lot of these have been purposefully plugged through the years. Farmers sometimes, for example, will put hogs in the bottom of these plugs, and they'll wallow and they'll stop up that sinkhole through the compaction effect of wallowing. Sometimes I've known that farmers will also put bales of hay down in these areas, and so that will attract their cattle. Cows will get down in the bottoms of those sinkholes. They'll feed there, they'll compact the ground, they'll stomp around. They do that over and over again, and eventually those become so compacted that they plug up and then they fill with rainwater. So those can be both important for agriculturally for watering places for livestock, but then they also can be exceedingly important as sort of these pothole wetlands for migrating waterfowl. All right, let's see. We have something in the chat box. Why is the Chert Plateau above Moulton Valley fertile, but the Chert in the Western Highland Rim is good? That's a good question. It has to do, I think, Laura, with the fact that the one near the Moulton Valley is additionally covered with alluvial deposits from the adjacent Tennessee River when the Tennessee River was higher. That means that those soils next to that major river have been fed with a lot of silt and alluvium and loam, which makes them naturally much more fertile.
Okay, so it's not the chert, it's the topsoil above it.
Exactly. You got an additional layer of soil above it derived from river flooding.
Perfect, thank you.
Okay, as an example of how, at least the northern half of Austin Peay's campus is in the Western Pennyroyal Plain ecoregion. And just a few years ago, we had built a brand new football field and football stadium, and then a sinkhole opened up on the northern edge of the football field. It took them a few months to fill this in. They had to come in with this cave system, this filler that you use to sort of fill caves with, and ultimately got it all patched back up, and we don't have that open sinkhole anymore there. Dunbar Cave State Park is on the very edge of this karst plain, and of course, if you're up on top of that hill, you'll notice, like in the prairie that we've created with SGI, you'll notice it's very rolling. It's got sinkholes. Those all lead down into and connect down into the cave system. Now you can't walk through those sinkholes and get to the cave, but certainly water can filter down and pollutants can filter down. That's what makes this area really tricky from a water quality perspective. All that agriculture that's so common in southern Kentucky and northern Tennessee, a lot of the fertilizers and the herbicides and the nitrates gets down into the water system through these sinkhole systems. Here's just another picture of Dunbar Cave. Of course, the mouth of the cave here has been highly altered by some development from the state park. You know, this is mostly 50 plus years ago. Looking down on the Pennyroyal, you can see some pretty cool features. Those sinkholes stand out. Here on the left is a photograph from up near the Clarksville Airport, Outlaw Field. You can see these sinkhole features here. And imagine then back when that was all tallgrass prairie, how you would have had this sort of dry prairie versus these little wetland areas embedded among the prairie. This is on the right is a photograph I took when I was flying in from Chicago back in December. And you can just see those beautiful reflective pools of those sinkhole ponds. This is somewhere over northern Robertson County near the Kentucky state line, north of Nashville. And these ponds were exceedingly important historically for migrating waterfowl like sandhill cranes and whooping cranes. We've got some running lists of birds that utilize these sites, and over 30 species of waterfowl and shorebirds utilize these depressional wetlands. Most of them, though, are temporary, and because of that, farmers in a dry year, they just plow right through these low wet areas. It's only the larger ones that tend to hold water permanently that usually are avoided for agriculture. Fort Campbell Army Base, most of it is located in the Pennyroyal Plain. The westernmost edge out here, kind of west of the impact zone, and the southernmost edges are part of the Western Highland Rim, but most of base is part of the Pennyroyal Plain. The Pennyroyal historically, we think, was around 3 million acres of open grassland. Some of it was almost treeless, open prairie. Again, that rolling nature is beautiful. We've got some photographs of some of the remnant grasslands. Like here's, both of these pictures, by the way, are from Fort Campbell. This is called Soup John Drop Zone. This is about 15 minutes from class. It's a 4 square mile open prairie. It's unfortunately been very degraded through time. And this is a remnant prairie that's on the edge of the impact zone at Fort Campbell, where just thousands upon thousands of blazing star wildflowers that are obligate to prairie systems occur. These are very important habitats for grassland birds, grassland insects.
You're gone.
As well. And then, like I said, there's town plains, the Mitchell Plain, both very similar in terms of their fairly rolling open plain type landscape. Laura? Hey, Laura?
Yep. I'm good. I was saying you're gone. You dropped out.
Oh, okay. Sorry. How much did you miss? I apologize.
I don't know, maybe just like before a couple seconds.
Okay. All right. Sorry about that, guys. I'll keep moving. I think y'all probably got the gist of what I was trying to say there, but I'll keep rolling. If there's anything specifically, let me know. Okay. All right. So with the Pennyroyal Plain again, kind of rolling, there's two things I want you to think about. One is the sort of the eastern and southern border of the Pennyroyal, and then the western border. So those are two very different things. So that eastern border of the Pennyroyal, when you come up here, let's say near Mammoth Cave, it drops off down into the bluegrass. Remind me though of what that zone that leads from the Pennyroyal Plain down to the bluegrass is called, specifically that line of hills right here in 71C. Who can remember that? How about Chase? Are you with us? Okay, Ryan says glacial maximum or something like that. So Ryan, that glacial maximum term is the name for the southernmost edge of glaciation up here. But what are we talking about? This term here, I'll just tell you it's called the knobs of Kentucky. or the Norman Uplands, or the Knobstone Escarpment. There's 3 different names there. And we can just call it the knobs, and I think we'll be okay. Okay, and then that's sort of the boundary between the bluegrass and the pennyroyal. As I said earlier, the boundary between the highland rim and the pennyroyal is more of a geologic boundary. The chert layer versus the limestone, that's the karst limestone layer is the determining factor. Now let's look to the north and sort of west of the pennyroyal. If we're here in Clarksville driving north across this plain, we get up to near Russellville, Kentucky and Hopkinsville, and then we encounter a low line of hills that are limestone. That's what we call this region 71A. And then likewise, if you're heading west from, let's say Louisville, you'll encounter that line of limestone hills. That's called the Mammoth Cave Hills. And then further west in this area that is in 72 here is what's called the Shawnee Hills. And it's mostly a region of sandstone. And I'm going to point that out. So broadly speaking, this hilly region of Western Kentucky and southwestern parts of Indiana and extreme southern Illinois, kind of this whole region right here that I'm circling is broadly known as the Shawnee Hills region. And as I mentioned earlier, some people sort of don't include the Shawnee Hills of Western Kentucky in the interior plateau level 3 ecoregion. I do, and I think that I've talked to a lot of people in Kentucky, and we tend to agree that it's best part of the interior plateau region. So let's dig into these Shawnee Hills a little bit. Okay, Shawnee Hills, when we sort of look at them, is sort of the opposite scenario to what we see with the Molten Valley. If you're coming across the Pennyroyal Plateau heading north, say from, and I'm looking at this diagram at the upper part of the image here. If you're going north here, see the north arrow, from Clarksville, say to Hopkinsville, Kentucky, then just around Hopkinsville, you begin to climb a low line of hills. And that's this first line that is right here, shown by the dividing line between 71E and 71A. That line is known as the Dripping Springs Escarpment. Some places it's pretty defined, in other places it's a little bit obscure. As you drive up onto that line of hills, you're getting into the region known as 71A, and that forms what's called the Mammoth Cave Plateau. The reason for that is over here on the right side, Mammoth Cave National Park is entirely located on that plateau, and the cave known as Mammoth Cave is formed in the lower limestone layers there in that plateau. Now, as you go across that sort of narrow plateau that is 71A here and over here, then you will eventually encounter yet another escarpment, another line of hills. This one's called the Pottsville Escarpment. That's the heavier black line right here. And that takes you from mostly being sort of on a little bit of sandstone, a lot of limestone, but it takes you up into a definite region with a lot of sandstone and coal. So this is a big coal producing region of the South right here. Okay, so there are a couple of escarpments there and a couple of plateaus that you need to be aware of. The Shawnee Hills is the uppermost one. The Mammoth Cave Plateau is the lowest one, or the middle one, and then the very bottom plateau that we're sort of at is the Pennyroyal Plateau. Notice the different limestone names through here. You don't need to know those, but you can just see the relationship between, like, the Fort Payne limestone, really we call that a chert. The Warsaw limestone, the St. Louis limestone. Those are really common limestones that are used around Clarksville, the Warsaw and the St. Louis. And then as you climb, you've got other kinds of formations like the Big Clifty Sandstone and the Pottsville Sandstone. So if you're into geology and you want to be a geologist, you really need to know that stuff. If you're a natural historian and a biologist, you need to know how to use it. You need to know when and where to go to get that information, but you may not necessarily need to recall it instantly. Okay. So there's the Dripping Springs Escarpment. Again, the Mammoth Cave Hills, sometimes called the Mammoth Cave Plateau. And guess what? As we cross into Indiana and we get into Illinois, they have different names. In Indiana, they're called the Crawford Uplands. In Illinois, it's called the Southern Shawnee Hills. So I wanted you also to note that this distinction here, from Indiana down through Kentucky, all the way over to here, it's recognized on your EPA ecoregion maps as the same level 4 region, 71A. When you get to Illinois, though, they change it to 71N, and they change the name of it. There's really no need for this. They are the same region. They just have different names that reflect different state usages. So for what I would advocate would be to simply call it all the same. And of course, as you can see, that's complicated by just so many names that exist. Seems like the leading name that most people use is Mammoth Cave Hills or the Mammoth Cave Plateau. Next then is that Pottsville Escarpment, which, and again, I just drew the blue and red lines here, just those short sections, but they actually go all the way around, right? They're not limited to just those portions. And that's the line that, again, separates the true Shawnee Hills to the north. But likewise, when you get over here to Illinois and Kentucky, this region 72H really does extend right on across and becomes 71M in Illinois. This is one of the few cases I can think of where there's a true sort of lack of cohesion between two states in these ecoregion maps. I think those need to be revised in time, and we just simply call it the Shawnee Hills across those two states. Any questions about that? Okay. All right, Shawnee Hills. Likewise, if you're in Kentucky, sometimes the name Caseyville Hills gets used, or Northern Shawnee Hills in Illinois. I'm going to advocate we just simply call it all the Shawnee Hills in general. All right, some key places in this region include Mammoth Cave National Park in the Shawnee Hills, a beautiful plateau with a deep stream valley here cut by the Green River, which flows through the park. A beautiful cave, one of the largest underground cave systems in the world, especially in the United States. The Blue River of Indiana is a gorgeous river that's also in the same Mammoth Cave Hills ecoregion. Very important. And then when you get into the more sandstone dominated areas of the true Shawnee Hills, you can see that sandstone sort of cropping out here on the right. This is up in Illinois at a place called Garden of the Gods, just off of Interstate 24. There's another look at that. Beautiful sandstone features, just incredible, landscapes. And this one is a site that I actually take a lot of my students to. This is about 30 minutes, maybe north of Clarksville, maybe 45 minutes. It's on the edge of that Pottsville Escarpment, and this is called Pilot Rock. It's up in northern Todd County, Kentucky. A lot of the people from the Army go up there and rappel and rock climb and train. A lot of kids go up there and drink beer and break bottles and spray paint. Unfortunately, it's really an abused place with a lot of trash and a lot of graffiti, but it's also a really, really super cool place with some great views. So then Mantle Rock, which is out in the western part of the Shawnee Hills in western Kentucky, is an exceedingly important place because the Cherokee, during the northern path of the Trail of Tears, I think that was 1838, when they were forced west from their homes in the southern Appalachians to Oklahoma, they camped here before and actually waited out the winter here before crossing over the Ohio and Mississippi rivers. Unfortunately, many of the Cherokee died while they were camped here. But this is a very well-known, famous landmark, a natural sandstone arch. And here's just a quick little historical marker. It says during the winter of 1838 and 1839, the Cherokees were forced to leave their Smoky Mountain homes for Oklahoma Territory. Mantle Rock, a 40-foot high sandstone arch, was used for shelter on their Trail of Tears. Since the icy Ohio River had no ferry traffic, the Indians sought a cover beneath the arch. Many died there. Mantle Rock was also a campsite for ancient Indians. Going back over millennia, this has been an important landmark. With that, everybody, we have wrapped up the interior Plateaus ecoregion.